So take that, Vigner. I don't know how long you've been dead for, but I'm coming at you.
Stay dead longer, because I don't want to hear your bullshit anymore. Waveforms look cute. Looking good.
Mike, sure. MV7, you...
Pretentious bastard.
Yeah.
Yeah, so how goes the writing sessions? Cam, you've done a couple of them now.
Yeah, dude, they're good. I mean, I think I'm just trying to make it like a weekly habit, because then even if I don't get any writing done during the week, it kind of just forces me to do it then. So at least keeps you on schedule. And then I think the more you write, the more you have in the back of your head, what should I be writing about? Ideas start coming together, and then, something, you have a thought and then you realize it kind of relates to maybe what you're writing about. And it just keeps you sort of the writing in the background the whole time as a background process, which is helpful.
And so what were the pieces that you were actually writing? What were you writing about? Because I guess today I'm Vaden Masserani from University of British Columbia. This is my conversation partner, Mr. Ben Chugg from Stanford Law, soon to be CMU. I got that right? Carnegie Mellon University. In, I guess, August, September.
Yeah, we're gonna have to switch up the descripring of the pod.
Yeah.
Because it's not going to be a research fellow and a PhD student. It'll be a PhD student and a postdoc. Switching roles.
Just switch it a little bit. But so I guess today we're talking about AGI, and you had some thoughts on that. But before we get there, I was just curious to know what you were writing about, and that'll kind of hopefully lead to the AGI discussion.
So have you heard of the
unreasonable effectiveness of mathematics?
Yes. Yeah.
From half of a word, I got it.
I don't know. How did you get that? That was fucking crazy.
We're just
all I said was ineffective something, and then you
the unreasonable effectiveness of mathematics. Yeah.
And who wrote that again? Eugene Wigner.
Yes. Yeah. So that one came up in our conversation with Mark Collivin, because it's all about what's the relationship between mathematics and reality.
His whole thesis is why is mathematics so effective, right? Physicists rely on math to describe reality, and just taking a step back, that's kind of an amazing thing, right? How can it be that we can describe reality with, relatively simple equations, and that these can make predictions, and we can deduce things about the math, we can derive things from mathematical statements, and then those also hold, and we can reason mathematically about the world this way. Does it have to be like that? What the what the fuck's going on? Math is just kind of this thing that we've either stumbled upon or created, depending on your point of view, and how dare it be so effective? Mm-hmm. But I think I've been convinced that that's just not true. And I think you can see it pretty easily if it's not true by just looking at all the kinds of math that don't fit reality very well. So it's not
all the kinds of reality that don't have math to explain it. So in both directions, it kind of...
Yeah. So I mean, the other direction is slightly harder, because you could just argue we haven't figured out the right math to describe it or something, right? Complex systems, people are trying to attack it mathematically with some success. But because of things like chaos, it's just very hard. But yeah, I mean, there's also physics, general relativity, for example, is sure, it's very well described by a very particular subset of differential geometry, but there's lots of other kinds of math that have nothing to do with the curvature of space-time or how reality works, right? And so I think the whole argument just relies on kind of picking and choosing the mathematics beforehand or after the fact, right? So you see differential geometry does really well at describing general relativity, and you say, oh my God, how can that be the case? But you're also not taking into account that number theory doesn't, that various kinds of abstract algebra doesn't, the Euclidean geometry doesn't, right? So you're just making a mistake of sampling on the dependent variable.
Is that all that's going on though? Because it seems seems almost like a bit of a cop-out argument to say that the unreasonable effectiveness of mathematics is just due to cherry picking.
Well,
is that what you're saying?
Sort of. So it goes a little deeper, right? It's how are we able to cherry pick? It's because we are inventing, we're coming up with axiomatizations of formal systems, right? And these have consequences, mathematical consequences, right? So we can write this down mathematically. We can follow the consequences. And we do this for a bunch of kinds of systems. And then one of these kinds of systems describes physics really well. But if it didn't, then we would have just chosen a different system, right? So if the universe wasn't well described by differential geometry, then we wouldn't be using differential geometry, We'd be using a different set of axioms that better describes it. So in some sense, we're sampling incorrectly from we're just generating tons of systems all day. And it's no surprise that one of these happens to fit reality pretty well.
Yeah, agree. But do I have a but there? I guess there's something kind of remarkable about being able to derive conclusions that can be experimentally verified from a small set of axioms. And you're saying, well, if they weren't verified or if they're falsified, then we would come up with different axioms and proceed. And I'm saying, yeah, that is how we do it. But there is still some magic there, I think, that it's still wild that from a small set of axioms, you can derive laws of physics. The fact that it's possible to cherry pick something that works, I still think is kind of amazing. Do you not? Because there is something amazing there. Don't you think? Or no?
What would a world look like that didn't obey that? So what would a world look like where it was so irregular in the conditions and so chaotic that you could not come up with a formal system to describe certain patterns?
I would say most branches of science that aren't fundamental physics. So from biology, sociology, economics, it's very difficult to get. And so it could be like that all the way down, right? It could be you can never use math to describe even the movement of particles. And the fact, it's very difficult to mathematize, say, anthropology. Let's just go right to the top. So what would a world look like where we couldn't do this? It would look like anthropology and psychology and all these disciplines that don't have mathematics underpinning it.
Right. So it's no surprise that mathematics lends itself more easily to systems that are more isolated. The more isolated and simple the system, the easier it is to be described by math. But so I don't know what the world is where as you keep going down in simplicity, right? You keep reducing the complexity of the system. At some point, I don't know what it would look like to say you could never describe that mathematically, right? At some point you're dealing with something that looks like a particle, right? Zooming around or whatever.
So your main point is that just we shouldn't be surprised that it works, contra Wigner's thesis that it's holy shit, it works. And you're saying, obviously it's going to work.
I think so. I think that's what I'm saying. Yeah. When you say it like that, I'm like, am I saying something that strong? But I think that's basically what I'm saying. Yeah. I think I'm saying by saying it, you're begging the question a bit. You're saying I think the it there is referring to a very specific math. Oh my God, we can describe general relativity as a pseudo Riemannian manifold. Oh my God, that's crazy. That's just something some random dude came up with in a math department. But had it not been that, it would have been something else.
I guess I can't shake the fact that I still think it's amazing that we can come up with these geometric structures and have it describe reality.
Okay, but that's a different thing, right? That's a marveling at human creativity. Not as the fact that once you grant that we can conjecture formal systems and logically deduce their consequences and do that mathematically, once you grant our ability to do that, then I think it's not that surprising that that's nice we can generate formal systems that describe reality. But I agree. I mean, just the fact that we can do that is fucking nuts. And we've never been able to recreate.
That's a really nice reframing.
Things that can do that.
That's a nice reframing.
So take that, Wigner. I don't know how long you've been dead for, but I'm coming at you.
Stay dead longer because I don't want to hear your bullshit anymore.
Yeah, I don't want to.
But so I guess in this process, you've also come up with some interesting new thoughts on AGI, and that's kind of the point of today's conversation. I have my new favorite thing. So when we record for 1 p.m., I can't be drinking. So now I'm drinking soda with frozen strawberries and lemon slices. So I'm ready. I'm ready, baby. Hit me.
I've never seen a man more ready for debate than.
Oh God! Well, I don't know if we're going to debate or not, but I got frozen strawberry and lemon slices, and it's so refreshing on kind of a hot Saturday afternoon in Vancouver.
So one thing I was trying to think through was what would be the consequences if deep learning, the current paradigm of deep learning, actually gave rise to AGI. Okay, so I know you don't think that can happen, and I also don't think that can happen mostly. But if it did, what would that imply philosophically? So that's just one interesting question to wrestle with. What would that say about empiricism? All this stuff. And another thing another piece of writing, I guess, that I was trying to engage with was just steel manning the AGI, AI safety, AI existential risk people. Because I think I often get kind of annoyed at the tactics that are used, right? It's which we don't have to get into. But yeah, I think I have like just a sort of a negative emotional reaction to it. But I wanted to see if I could like really sit down and like try and steelman their case. And in doing that, I realized there's like a lot of different threads at play that I think aren't often disentangled, especially by people who like criticize that community. I think there's like sort of more going on there that originally meets the eye. And so I thought it'd be fun to just have a chat where we pull apart some of those threads, see where we agree and disagree, try and look at some of the implications if like we happen to be wrong about AGI, etc. And then we'll just see where we agree, where we disagree and stuff. So broadly, I guess there's this movement in some researchers in AI, some just external to AI, that have become very concerned about rogue AI, right? And like current systems either developing like general intelligence capabilities, so becoming like human-like in their generality, but super intelligent, and sort of running amok. And this subfield we'll call like AI safety, and has like started to grow in recent years, especially as we've seen narrow AI become like more and more intelligent. So narrow AI meaning AI that's just trained for a very specific task. So image generation or language, natural language understanding, protein folding, take your pick. Okay, so that's the setup for like what the AI community is sort of.
And so like
the AI safety community.
And OpenAI has a big wing dedicated to AI safety research. So does DeepMind. I believe there's areas of the NeurIPS conference that receive papers for AI safety. So it's pretty well established. It's a well respected field of AI, and it also is where the effective altruism, less wrong people spend a lot of their time thinking about the potential. And so it can range from fairly immediate downsides of AI, so say unfair racial profiling for recidivism rates, all the way to the sci-fi paperclip stuff as well. So it's just any discussion on how do we make sure that AI safely interacts with human beings is under the purview of AI safety.
Yeah, which makes it kind of hard to talk about, to be honest, because there's like so many people working in that space who have very, very different objectives and like very different ideas of what like bad AI systems look like. That trying to grapple with the entire thing is difficult. So there's definitely issues with like, biased data in AI, it being deployed haphazardly and causing, there's like deployment issues where it, causes like unjust outcomes, stuff like that. I mostly want to focus more on the sci-fi end of AI safety, just because I think the other stuff is pretty mundane, understandable AI research, where you're just trying to dig into the specifics of these systems and like give them, more balanced training data, or figuring out how to like weight different things differently to achieve desirable outcomes. But yeah, then there's kind of like the sci-fi people who are worried about like AGI is taking over the world. Like we wake up all of a sudden and fucking Hal is, telling us all to stay in our beds and we're screwed. Yeah. Okay. So the first claim is that this sci-fi AI stuff is not only a concern if we actually get to artificial general intelligence, meaning actual like human-like generality. You can be pretty concerned about AI safety even if we just have narrow systems that are extremely competent and powerful in the handful of things that they are trained at.
So you can be concerned only looking at narrow AI, but also staying on the sci-fi end of that? Or are we now looking back to the normal end of it? Because I think
that's a good point.
It's totally reasonable to be concerned with, say, autonomous weapons and attaching like guns to drones and allowing it to find its target without having humans in the loop. So that would be a total concern. That's narrow AI, but I wouldn't say that's like in the sci-fi side of things. So which part of the
the concern sphere? Oh,
the concern sphere.
I want to try and say that it can be kind of both. Like if you imagine, like, okay, so GPT-3 is like an incredibly impressive language model. So if you imagine like GPT-4, 5, and then you imagine a system that like Gato or something that's trained on not just natural language, but now can do image generation and can solve a bunch of like specific tasks, but has the whole has like read all of Wikipedia, read all of the internet and stuff. If you integrated that with society, or just like, let it loose sounds like it's a weird moniker, but if that gets sort of unleashed too quickly, I can see a pretty valid concern that could upend some shit pretty fast, like geopolitically. Like that could cause some serious problems, even just considering like mimicking humans and just causing a lot of instability.
Okay, so let it loose can be, I mean, it really just try to pin you down. So, I could imagine you could make a public API for, say, Gatto. So Gatto, for the audiences, came out of
Fuck.
It might be Gato. I don't know.
Actually, I have no idea.
Came out of DeepMind, and it's really impressive. So it uses transformers, and it just predicts the next token given a sequence of tokens. And these tokens can be words, or they can be actions in a video game, or it can be chat dialogue or something. So I can imagine an API that's just released now. Anyone can use the system and perhaps start doing nefarious things with it. Or do you mean let it loose, just like plug it to the internet and then it starts making its own decisions about what it's going to what it's going to tokenize? And that's where I think it starts getting sci-fi, because you have to start speaking about it in anthropomorphic terms, right? So I think a huge component of this AI safety stuff is the assumption is we'll be able to get to a place where these systems can start making decisions without human beings involved. And I'm fairly steadfast on the side that in order to get a system that can start making decisions without having human beings in the loop is going to require a giant philosophical insight that's not based on empiricism and all this stuff. So I guess, so what do you mean when you say, so I'm still trying to get you to this space of, are we in the sci-fi land or are we in regular land? And if we're in regular land, what does it mean to let loose one of these systems? Do you mean just making it easy for people to use it? Or do you mean somehow it starts making decisions on its own?
Yeah, maybe I'm not in sci-fi land. Maybe I'm more thinking of stuff along the line of just like deep fakes and like not understanding, you see clips, you don't know whether it's real or not. So Shinzo Abe, Japan's former prime minister, got assassinated yesterday. You can imagine a world where everyone thinks that happened and it didn't happen. Right. And now you're trying to and you can imagine that with a current prime minister, right? So you wake up, you think Joe Biden's been shot. Now you have
this kind of thing already happens. Like, wasn't there one about Shia LaBeouf being killed and he's like completely alive and fine? And there's all these like instances of death rumors going around with certain celebrities. And then they turn out to not happen.
If that's not an existential risk, Vaden, then I don't know what is.
They're coming for Shia LaBeouf. They got to get through me first. Damn it. Yeah. But
right. Okay. So I guess I agree with you. Like, it's hard for me to imagine a sci-fi like scenario in which we just wake up and the world has been captured by a narrow AI. And so, okay. Sorry, AGI people or AI safety people, I couldn't steel man you on that one, but I'm trying my best over here. Okay. But that does justify a certain amount of quote unquote alignment research, right? Like maybe not along Miri's lines, or like, I don't know what the hell they're doing over there. Last I checked, I think they just gave up on the whole.
Oh, is that true? That's
kind of, well, so I think so.
Yudkowsky's writing these crazy screeds about how we're all going to die. Like, he's just flat out saying we're all going to die now, which is like, if a percentage of his readers actually believe this shit, it would justify going around killing like DeepMind researchers because to prevent apocalypse. Which is wild. Yeah,
it is wild. And it's that kind of stuff that like really turns me off the whole idea. So I'm trying to be as generous as possible without indulging in my annoyance for that kind of shit. But it really reminds me of like radical environmentalism. Like, it's like the exact same thing, right? Just like there's no solution. We're all fucked. It's game over. And I don't know if this will go in the pod because I don't know if I want to take pot shots at Yudkowsky, but I really feel like he's had like a phase shift in his brain. Like I cannot understand his writing anymore. Like, it used to be, you could disagree with it, sure, but like his writing was like clear, crisp, beautiful. Like, his sequences and stuff are like quite amazing works of just literary accomplishment. But recently I'm like, he'll write something and there's just semicolons all over the place. Sentences are like paragraphs long. I'm just like, dude, what are you talking about? Like, it. Well, so what I'm trying to focus in on like the AI safety community. And so it seems like a lot of people from the outside are saying these people are crazy because they're just worried about like rogue artificial general intelligence. And I guess my first claim is that it's fair to be worried about AI safety, even simply in the presence of like quite powerful, narrow agents. Just because they, maybe not on the sci-fi end of things, but they could just conceivably create a lot of havoc, right? And so worrying about how to have like robust systems that are, you know, extrapolate well to new situations, that are, you know, privacy preserving, like all sort of the typical concerns of AI, whether you call this like alignment research, whatever. But I think there's definitely a role to play for AI safety stuff there. Okay. It seems like we more or less agree about that.
Yeah, I mean, I would just put it under the purview of just like responsible engineering. Like an example is self-driving cars. People thought they'd be around by now, but it's just very hard to make them safe. And I think that's how a lot of AI safety quote research is being done, is just you can't put these things in market until you know that they're not going to cause harm, and so they don't go onto market. Or another example that was often used is like recommender systems and recommending conspiracy theory videos and that kind of thing. That's totally an AI safety concern. And as soon as companies realized that this was a problem, they started changing the way that they made the recommender systems. And so I guess I kind of challenged the idea that there's something unique about AI, when I think that most engineering systems, to make them safe, have to undergo huge amounts of scrutiny and care before they're deployed. And furthermore, once they are deployed, if we realize there's unintended consequences, then we modify, we continue to upgrade and improve. I think maybe some cases where there's special concern with AI would be like in autonomous weapons and in facial recognition technology. But again, these things are constantly up for debate. And there's like a giant letter that was sent around amongst all like academics trying to put a prohibition on autonomous weapons. And so there's a lot of legit work being done that could be described as AI safety research. But typically what is the kind of things you hear under the banner of AI safety is this more sci-fi stuff. And that's where you and I have been, I guess, quite critical.
Or unless at least you hear that out of various communities. But my sense is that like, if you talk to an average machine learning researcher who writes that they're interested in AI safety, it's probably pretty standard robustness and generalization research and stuff like this. Yeah. Okay. Nice. Okay. So let's just fucking get into it and talk about AGI here. Let's go.
What are your thoughts, man? What are your thoughts?
If you just grant the possibility of AGI, there are some interesting things in AI safety to talk about that I think aren't talked about by like the Deutschian crowd, for example. So I think the Deutschian crowd will say, well, AGI will just be a person. So there's like nothing to worry about there. It'll be open to being like fallible. It'll make mistakes. We can reason with it. It will be like a moral agent. Yeah. But it does seem like the idea of like a superhuman AGI does actually make sense, because if you just grant that like a system is AGI but artificially built, then its processing speed will just be like so much faster. And so if you could build an AGI, it does seem like there's something to worry about there, insofar as like how it's going to communicate with humans. And like humans take advantage of other humans all the time, and some humans perpetrate evil acts all the time. So I don't see why you could just shut down the possibility of, again, this is all just granting you can build an AGI, but I don't see how you can just shut down the possibility of being worried about it simply because you say, well, you know, it'll just be a human. It'll also make mistakes and have morals, etc. That seems to be that's like a pretty weak argument.
Yeah, like I've never been a huge fan of the Deutschian response that it's just going to be a person, because I feel like it's kind of playing games with definitions a little bit. So it's kind of like they define, so Deutsch defines person. So he wouldn't say it would be human. He wouldn't say that because he doesn't have a specialized definition for human. But he does have a specialized definition for person. And he defines a person to be an entity that can create explanatory knowledge. And if that's what you mean by person, then almost by definition, AGI is going to be a person if AGIs can do the things that human beings can do. But I feel like I don't like that definition, because what about children or like infants or disabled people who can't like create explanatory knowledge? Are they all of a sudden not people? It just seems like when I think of personhood, I think of more than just the ability to create explanations and explain stuff. And So it's fine if you want to define person that way, no one can stop you defining something. But I don't know if it's a super satisfying response, because just like there's huge variation between Einstein and toddlers, there's going to be huge variations between artificially intelligent entities and human beings. And so it does, like, I totally take your point that it seems like a bit of a cop-out, but I think to defend Deutsch, I think that the more interesting point is that knowledge can only be created one way, and that's through this trial and error process. And we know that's a necessarily slow process. So it's not quick because you have to come up with ideas and then you have to test them against the world. And the testing them against the world component is where things are slow, because it's hard to run experiments and it's hard to build hadron colliders and that kind of thing. And so this idea of like the Foom exponential takeoff equally doesn't seem to be persuasive, because we know just how slow knowledge is produced and how it takes a lifetime of study to make even modest incremental gains in our understanding. It could be the case that supercomputers can do this faster, but even when you have giant supercomputers that can do huge amounts of linear algebra, that doesn't mean that they're necessarily producing knowledge any faster, because it's the experimental part that's one of the big
right. But if you had like the creativity of a human brain, but also the memory and speed of a computer that could have access to like all of Wikipedia, say, or like all of the internet, it seems like you could test guesses pretty fast. And I'm not sure if generating knowledge is the concern here, right? Like if you just imagine, I mean, humans can be immoral. So presumably an AGI could be immoral. And so if you imagine just an immoral, super competent AGI, I think that's the concern. Like just imagine like a super competent Hitler. It seems bad. I mean, I
can imagine all sorts of things, right? But it's like,
well, no. So again, this is like, you have to grant that we are either close to or can build an AGI, which I know you're not willing to grant, but if you grant that, right? So you have to put yourself in the mind state of someone.
Anything can come, right? Like,
okay, well, no, that's not
like, I just have a different. It's
honestly granting a logical impossibility.
No, but it's like, okay, let's start imagining a world where aliens come down and they're super duper intelligent aliens, and it's like, okay, if you want to play that game, you can, but it just seems like tennis without a net. It doesn't seem like there's any constraints to guide our speculations, because we've already granted something that, like, once we're there, we're so far away from where we currently are that the world is going to be different in an infinite different ways. That it's like that Robin Hanson book where he talks about
Age of M.
Yeah, Age of M. He talks about like what a universe would be like when we can simulate our minds in silicon. Right. And it's like, okay, just grant that one assumption that we'll eventually get there. Now I'm going to start building on top of that, where it's like, okay, but now we're just in sci-fi land. Like, we're totally in sci-fi land because we've granted an assumption that puts us so far away from where we currently are that it's hard to speculate. But I'll grant it, because I don't want to be a fucking stick in the mud. But I just want to grant it with
a fucking stick right now.
I just want to grant it with all these caveats that, like, I don't like thinking in this manner, because now we're just so far away from what's normal. But yes, right. So you want me to imagine a super intelligent Hitler.
Yeah. I mean, I want you to put yourself in the brain of someone who is convinced that the scale hypothesis is true. The scale hypothesis just meaning, like, if we make, we have these neural networks right now, they're a fraction of the size of the human brain. There's one philosophy of mind out there that just says scale these things up, and that's where everything will be emergent properties that follow from that, and that's how we'll get AGI. And I don't actually know how rare of a position this is, right? Like, I think Nando de Freitas, who's a big name in the ML research community, thinks this. So we just scale up the systems that we have now to the size of the human brain in terms of the number of neuronal connections, and boom, we'll have these artificial generally AGI systems. Okay, so some people think that. Now put yourself, and so I know you don't think that, but put yourself in the mind of someone who does. You can understand, I can start to understand some of the arguments more, right? This is an exercise in cognitive empathy, Vaden, as Robert Wright would say. So I'm just saying, if you imagine that you're one of these people and you're convinced AGI is a decade away because all we have to do is scale these systems up, then I can understand why some of this fear is here. And I can also understand why someone's like Deutsch's arguments just seem to totally fall flat, right? Because you have people running around saying, well, AGI is human, there's nothing to worry about. I think I heard one debate somewhere where someone said, well, we don't have to worry about AI taking over things because we have the law, we have property rights and things like this. I can understand that if you're one of these people that thinks AGI is just around the corner, that's an insane thing. That's an insane argument, right, from their perspective. So I guess my claim is that the people on the other side of the fence need to do a much better job of like grappling with the actual views, or they need to do what you're doing and going to the root of the problem and saying like the assumption that we're about to generate AGI is way out. Because if you grant that assumption, I think a lot of the arguments coming out of like the AI safety community are pretty coherent, right? Like now you can actually start worrying about things like evil Hitlers. And,
but the assumption that they're granting is the assumption of omnipotence. Like they're basically assuming an omnipotent entity, and then they're freaking out about it. Where it's like,
or just something super, super competent, right? Like there's just bad. I think the point of the alignment problem is like you want this thing to be one of the good humans, or one of the decent humans. You don't want it to be Mussolini, right? So if you have a super, and so I can understand why people are concerned about aligning an AGI, because you don't want, there's bad humans. So presumably if an AGI is as general as a human, there could be bad AGIs. And that's all you need to get the argument off the ground.
Yeah.
Besides the assumption of AGI, which is
well, it's based on all sorts of assumptions. Like, so can I understand why people are freaking out about it? Yeah, sure. There's a lot of writing that says like intelligence is just going to keep scaling up, and eventually it's going to get more intelligent than us, and then you can be off to the races where you can start speculating about what that's going to be like and stuff. But I just challenge the assumption, and I challenge it for a number of different reasons. One of which is the empiricism thing, that we know that you can't just train a system on observation after observation. And after a certain number of observations, it's all of a sudden going to generalize to being able to deal with new things. Another way to put it is, all of these systems require training data, and it's a human being that decides what counts as training data. And so humans are the ones that say, okay, this is an example of an observation. This is an example of an observation. And we create these artificial worlds where there are patterns to be found. And then we make systems that can discover these patterns. And that's very powerful. But Popper's whole point is that you need some inbuilt structure which can even discern what an observation is in the first place. And for all these systems, human beings serve as that structure. So I claim that until we figure out a way to train systems not using gradient descent on training data, where the training data has been chosen by human beings, if we're still operating in that paradigm, then there's going to be no way to get a human being out of the loop. This is one argument. Another argument is to think that these systems are getting better and better on some domains, and these are domains which are particularly conducive to the techniques that we currently have. So it's the famous example of the searching for the keys under a spotlight. It's like we're going to be really good at playing video games and doing token prediction on data sets where you have billions and billions, if not trillions of data points. And games, because you can do repeated play. So of course we're going to do well on StarCraft and arguably more complicated games after that. But there's no reason to think that that is going to scale to domains where we don't have this problem structure, like self-driving cars or
just common sense. I mean, that's
common sense reasoning. So much of these AGI fears are built on this idea that, well, first we beat chess. First we beat checkers, then we beat chess, then we beat Go. And so just like 3 more video games, we're going to be beating geopolitics, and we're going to be beating, choose the next hard example. But progress in these domains doesn't necessarily mean it's going to transfer to other domains. And so like one factoid I just learned about Eliezer Yudkowsky is before he was freaking out about AGI, he's freaking out about nanotechnology, nanobots. And he thought nanobots were going to kill us all and stuff. And so it's like the reason I have difficulties with all this is you start with the assumption of basically an absurdity, and then you start speculating from there, and then you start working yourself into a lather because you can't figure out how to solve it. But it's like, well, just back up to the absurd assumption you granted, and let's see if that makes any sense. And then we can start making progress on the subject. But
okay, I mean, so that was good. So it's definitely fine to criticize like the assumptions that we're actually like even close to generating something like AGI. All I wanted to get across was that that's where people that are criticizing the AI safety community, the AGI fear community, need to go, instead of talking about like, oh, an AGI is going to be a person, and so we don't have to worry about it. Like all I'm saying is those arguments are just like are super flat and are not the one, or I think are wrong, and two, are not the place you actually want to like start the argument from.
Yeah.
So that's all I wanted to get out of that. So, but now let's
agreed.
Yeah, so now let's actually like dive into AGI and empiricism and stuff. So if I had to bet, I definitely agree with you. And like, yeah, I wrote that piece quoting Melanie Mitchell like a year ago, basically making these kind of arguments, right? Like what you're averaging and extrapolation of current data sets are not the same thing as like the actual creativity coming out of human minds. And these are not just on a continuum. These are actual just like differences in abilities. And we have no idea how to program the latter. And so I had to bet I would agree with you. But so one thing that got me thinking was actually in our last episode, Popper had the thing where he's talking about the machine argument. Right. And he was saying, as soon as you understand all the causal mechanics of the machine, you look at it up close, you understand how input is being traced to output. Now you no longer argue with it. Right. You're not taking it seriously as a person. And he can make this argument because he thinks humans, we're not deterministic. Yeah. Right. So he would say, I think you couldn't reduce humans to that level. I think that's what he'd want to say. Right. There's no way to actually understand humans as like input output machines.
His line is he wants to say that human beings are not machines, right? So he doesn't think that the world is deterministic, and so human beings are part of the world and wouldn't be deterministic, but he would want to say that human beings are not just sophisticated, complicated machines.
Right. And so I started thinking like, okay, if I was wrong in my assumptions about AGI, in what way would I be wrong? And I think it would be something like this. If you looked at the human brain at just like you consider like you have a map of the human brain and you feed the eyes some imagery, and then you look up at what parts of the brain light up, and then how those, what neurons are firing, et cetera. And then you trace that to how that is affecting certain muscles. And then the person says something. Okay. So you can just look at this like a super, super complicated machine that we're trying to understand. You might be tempted to say, just looking at the human from that standpoint, oh, this is purely reductionistic. There's no creativity happening here because we can see what's going on, right? You have an image fed in and you have some language spit out. There's a bunch of connections happening in between. We're not sure what's going on there. But this would miss the fact that humans are like engaging in the world of ideas, et cetera, et cetera.
So the setup that you want me to imagine is you have the brain, you're omniscient, and so you can see all the things that's happening. And it's given some certain sensory input and it produces some certain sensory output. But can we make that a creative process? Can it be it's looking at a landscape and the output is it's painting, impressionist painting or something of it? Like
for sure. Yeah.
And so you're saying that even in this case where it's doing something creative, we know all of the firings, and so we've removed the creativity from the machine. Is that?
Well, I don't want to say you've removed the creativity. I want to say if this is all you knew about a human, right? So if you just saw this, say you're not even told it's a human, okay, right? Like say you're just looking at this on I'm thinking of some giant computer screen, and you have the input as a landscape, and then you have some map, 2D map of the brain, and you're like, oh, look at all these things lighting up. It's crazy how it's doing this. And then it spits out a drawing, right? You're like, oh my God, that's crazy. So in some sense, this is what we're doing with neural networks, right? We're looking at it from a very particular point of view, which is like a reductionistic point of view. We're looking at like the purely material level. And so again, the question I was asking myself is like, how could I be wrong about this? And I think one way is if creativity is like an emergent feature, right? So you can't, and which I think it kind of has to be, right? It doesn't seem like you can see creativity when you're looking at the level of like neurons firing in a human brain. And so it'd be surprising if you could see creativity at the level of gradient descent in a neural network.
Because I definitely think of the mind and consciousness as an emergent property. Okay. And I would want to fold creativity in there, that creativity is something that the mind does. So I'm totally down to view creativity and mind and knowledge as emergent properties of the human brain.
Right. Okay. So if that's true, and we don't have a good theory of when it's like how it's emerging, like what do you need to make something emergent? In this case, like what do you need to make creativity or consciousness of the mind emergent? Then like how can you be sure that a neural net is not being creative in some sense, right?
Because we know through Popper's arguments that it's not sufficient to just give example after example after example to a blank slate. So it's all of the arguments against blank slatism that are in play here. And so we don't need to say we know how creativity emerges. We just need to say we know that simply giving it example after example isn't sufficient to have creativity emerge. Assuming
it's going to emerge the exact same way it emerges out of a human mind, right? So you're drawing the parallel with humans. You're kind of there's a built-in assumption there that creative module or like intelligence in general will look the exact same way it does in a human. There's no alternate route to get there than by human biology or whatever's going on in the human brain.
So the claim is kind of, it might not be possible in humans, but in neural networks, you could have this emergent creativity coming out if you give it enough examples. Is that?
Yeah, it could be this is like an alternate way to get like creativity is emergent in humans and in neural nets. Sure, in humans, like, you know, we're not blank slates. We have built-in genetic knowledge. I don't know if you can say therefore, I mean, neural nets are fundamentally different than humans. And this, you know, I guess this is the point. And so you can either say they're fundamentally different than humans, right? We don't just learn by like feeding example after example. So therefore, neural nets will never be creative. That's one way to go. The other way to go is maybe there's like an alternate way to get to creativity.
Well, so I think the focus on humans is due to the fact that humans are the only general purpose intelligent system that we know of. So it's not like we're just using that example out of many possible examples. It's like the brain is a singularly unique entity. So that's one. Also, it seems like not knowing how creativity emerges in human beings is a bit different than hoping creativity will emerge if we do this thing that we know doesn't work on human beings.
Right.
Because with the neural net stuff and with the Nando de Freitas, it's like when you train these language models on text, there's no interaction between the model and the world. It's just simply token prediction. And that can be incredibly powerful when you're not like, it can be powerful to come up with sequences of tokens that match Wikipedia, but it has no understanding of the world at all. It just knows that the cat sat on the blank. It's likely to fit in the word mat there because you've seen hundreds of, so it's there's no connection to the world.
Yeah.
And like one thing that I noticed with Georgia growing up is like she's constantly feeling things in her environment and like picking stuff up and interacting with it and putting it in her mouth. And it's this constant interaction with the external environment, which is the source of like her learning. And so neural nets don't have that because all they have are what human beings give it, and we'll give it data sets that we've determined reflect some aspect of the world that we think are valuable. But to think that all of this stuff is just going to emerge out of more training data, like ignores so much of what we know about how humans learn about the world. It's through interaction, through experience, experimentation, tactile feedback, all that stuff. That like we don't need to necessarily know how creativity emerges in the brain because we obviously don't know how that works. To know that the brain has a lot of inbuilt structures that neural nets just simply don't have. Yeah.
Melanie Mitchell wrote a really good piece about this recently, just arguing that like this is why these things don't display common sense and they can be fooled by, you know, just various word problems because there's no, you know, when you say the truck is red, when people say that, you have this sort of pictorial representation in your mind of trucks and red and like what that means. And you could walk outside and touch a red truck and you can walk outside and touch a blue truck and no, that's not a red truck, etc. And this is like much more than just obviously much more than pure correlation. And so that actually made me think that like embodiment will probably be a big part of AGI when we actually get there. Like we're ignoring the fact that it actually needs to interact with the world, and probably physically would be my bet right now. Like you need some sort of like physical interaction with the world. So yeah, as I said at the beginning, my bet is definitely this is definitely the wrong track to go via AGI. But I mean, I guess, yeah. I mean, so have you been surprised at all by the competence of certain, for example, like GPT-3? Like, have you been surprised? Like, I will admit that I'm surprised at how good these things are sometimes. I'm less surprised by like something like Dolly, because I think there's just like a lot. If you train something unsupervised on a fuckload of images from the internet, then there's some weird shit on the internet. And also there's less of a standard of what makes sense, right? If you just put in a prompt and it generates a crazy image, there are probably billions of things that could have generated that would be like, whoa, that's a crazy thing, right? So there's less of a standard for performance. But for GPT-3, I am like blown away by, and obviously it's hard because you don't know what was in the training set, right?
Yeah. So there's a couple of moments like the whole Google employee who had a conversation with the thing. Like the conversation was fairly impressive, and so a bit of surprise. But then I think about just the sheer amount of training data which is available, and so I expect there to be really interesting and powerful systems for which we have whatever the step up higher that from terabyte is of data. So text, images, video, audio. There's huge amounts of data on the internet. So you can imagine, like in 5-6 years, there'll be Dolly for videos. So you can just type in a prompt and a whole video will be generated. And that seems super plausible. And I think there's already some work that's coming out that's doing that. But then it's going to stop. And then we're going to realize this only covers a small subset of things that human beings are trying to solve, like medicine, like outer space exploration, like anything, again, interacting in the real world. So training robots to walk and move in a humanoid fashion will be very challenging because we don't have a lot of walking data. So expect to see further innovations in places where you have unlimited amounts of training data. And then there's also going to be like, eventually a system will be trained on all of the text on the entire internet. And then where can we go from there? It'll be very good, and it'll allow some really powerful things. Like you'll be able to do like natural language interfaces to SQL databases and stuff, better search engines. That's all going to be great.
Write a lot of our code for us, which would be nice.
Yeah, that'll be great. But then progress is going to stop, and then people are going to realize, well, we still have robotics, we still have healthcare, we still have all these domains that are really challenging. So my surprise, to answer your question again, my surprise was there, but then tempered by just thinking about how much data is available in these application areas.
Yeah, fuck. I mean, I agree. I'm trying to fucking do my best to steel man here, though. So when we were chatting last time, I don't think this was on the pod, but this was elsewhere. I think you said like one criterion for AGI that you would consider would be like sort of a referee process where you're like arguing with someone, you're trying to make a case for like an idea you have, and they push back and then you push back against that, etc. This seems like a pretty bad criteria for AGI. Like it seems like we're not that far from that. Like I wouldn't be surprised if unless you include like the actual novel idea, I guess. But it seems like just arguing with like a referee seems like a process that we're not that far away from. Not on every topic imaginable, obviously. But it doesn't seem like you want to make that your Turing test.
Yeah, it was, I think, a piece from Gary Marcus that's just made me start thinking that the Turing test isn't a very interesting test anymore. That for any one thing you ask, it's possible to develop a narrow AI to do well on that one particular thing. But humans are characterized by how they're good at any. They can both climb to the top of Mount Everest and make progress on the twin prime conjecture. And so trying to come up with a single criteria, I think, is the wrong way to go about it, because it's kind of like saying, I'm not going to look at how the system actually operates. I'm just going to look at if it can do this one thing, and that's enough for me. Whereas I'd rather say, well, if we have a system, let's actually look at how it's made, and let's see if there's any reason to think it's actually intelligent, or if it's just doing pattern recognition. So I've kind of changed my thinking a little bit from trying to come up with different variations of the Turing test to wondering if it's even an interesting test in the first place.
Yeah, I mean, I feel like you're changing the question a bit, though. Okay. I mean, like, let's say we're at a state where you can never tell whether something you're interacting with on the internet is a person or not. That seems like you might just be like, that's not AGI, fine. But that seems like a demarcation of some very interesting phenomenon that we should be either concerned with or that we should pay attention to.
Yeah, fair. And then you could say, well, right? And make them embodied too. And so now you can't.
Well, and like not even embodied. I just mean like there's something significant about even something being behind a screen and not being able to tell whether it's a human or not, right? Which was like the original Turing Test, right? Like you have chatbots, they don't have to look like humans. You don't have to be facing it across the table, and it doesn't have to be able to go outside on a run with you. But I think Turing's point was that there would be something very powerful about a system, even hidden from your view, that would trick you, right? That you couldn't tell with better than 50-50 chance that this thing was a human or not. And there is something powerful about that thought experiment.
Totally. But I think we're approaching the place where like it would be possible to make such a system.
Right.
Based on the
which
amount
is
of data.
Substantial. That's a substantial thing.
But we know that system isn't intelligent.
So, okay, that's
we know
fair,
through
right?
external, so we know for external reasons beyond the Turing test that is not an intelligent system, but yet it can beat any textual Turing test that you throw at it. Indicates that the Turing test itself is out of date because we figured out
as a test of general intelligence. It's out of date as a test of general intelligence, maybe, but not as just an like this is it's sort of it's like a litmus test for just a fascinating kind of phase change in like how humans would interact.
Yeah, because how much like chat data is there? Like Facebook Messenger, Google Hangouts, all of these. Like you could train a system on literally all of it, and it would learn to respond to texts in a humanoid way. But yet we know it's not intelligent because it's just mindlessly parroting. It's very much like the ELIZA system. It's just more sophisticated. But it's like a giant database of looking through all of the text responses from every person over the last 25 years. And it's going to store that information not as a direct lookup, but through the weights of a neural net. But that's about the same thing. And so because we're approaching a time where the Turing test, like it seems plausible that we'll get to a point where you can text with anybody and can't tell if it's human or not. But we know how the thing works, and we know that the way it works is dumb pattern recognition. And so that to me indicates that the Turing test itself is out of date.
Yeah, I agree. Again, like as a test of actual AGI, but not as just an interesting test. Like I think
it's still interesting. Yeah, for sure. It's a good goal.
Yeah.
Well, and then we're going to get to the stage where like you can train these systems to respond like a particular person. And then you have all these interesting ethical dilemmas of like, let's say you die, some freak accident, and I take all of your chat history and create like an artificial chat Ben and just respond to Ben just as like a grieving process. Like I want to keep you alive via this text thing. Like that's possible if that's not already made already. And so there's some interesting ethical questions about if that's the right thing to do or not. But continue. Yeah.
Well, no, yeah. So this is good. I guess the next place I want to go is just discussing or drilling into what you mean by creativity a bit. Like, what does it look like to generate? Not trying to define creativity, but like, I guess what would you be satisfied? What would it look like to generate like a new idea? Like, what test could it pass where where you're like, holy shit, that's a new idea, right? Like, because it's just, there's like, current systems kind of at a very basic level, right? You can think of averaging past data or like extrapolating a trend of past data, like interpolating between the data points, right?
Yeah.
And so in this way, you can get new answers to things, but it's still completely informed by your past data, right? You're either just like interpolating somehow between data points or taking the average, right? So you're like generate a new game and it's like, well, I'm just going to average over all games that I've seen and then apply some basic logical filter or something, right? And then that's kind of a way to generate a new game. Whereas I think if we saw that going on, we'd say, well, that's not really creativity. It's just like taking everything it knows and averaging it in some clever way. But like, it's hard for me. So, I mean, okay, I guess the thought experiment I return to always is like, say you trained one of these models in the time of Newton, like just before Einstein. Is it completely infeasible that it would come up with general relativity given, well, I don't know if this makes sense. But let's say you had stuff like Wikipedia. So you had articles on differential geometry, all this stuff. Is coming up with general relativity only knowing Newtonian mechanics, but knowing a bunch of like advanced math and being able to read data sets of observations about the speed of light and shit like that? Is that impossible?
Yeah, I have no idea. Well, I think kind of what you're getting at is it's like all new ideas are combinations of existing ideas in some sense. Like this is one of Matt Ridley's big points with ideas
having sex, right? Yeah,
ideas having sex, and it's all it's Like, we should dive into Matt Ridley at some point in the podcast. He's
I would
great.
love to.
But I think he talks about how like all innovation happens like simultaneously across. Like there was a bunch of different inventors of the light bulb. If Einstein didn't invent relativity, somebody else would have put the pieces in place pretty soon. Like it was like wondering what was going on with Maxwell's equations, with the fact that the speed of light is constant no matter which frame of reference you're in. Like that was just begging the question of like investigation, right?
Yeah.
And so to your first point of like what is creativity, I tend to use creativity as like a placeholder word for whatever magical thing the human brain can do that I don't understand, because it's hard to say like what counts as a new idea in advance, but you definitely know it when you see it. Like when you're reading Deutsch or when you're reading like Nabokov, like each paragraph just oozes with new things that you haven't heard before, haven't seen before, and you just think like, how does he do it? I think Douglas Murray said in his podcast conversation with Lex Friedman, that when Douglas Murray, when he's reading stuff now, he just thinks like, either I know how they've done that, or I have no idea how he's done that, or they've done that. And that's kind of how I want to think about creativity. It's like when I see like a brand new idea, I think I have no idea how this person has come up with this thing. And so this is all vague and hand wavy, and I don't think we have a good answer. And I think that any criteria we try to set will be hackable. And it's like you set the criteria, and almost by definition, creativity is something which will creatively overcome any criteria that you set for it, you know?
Yeah. I mean, okay, so to push back on the Douglas Murray criteria there is like, I'm sure you've had the experience of reading someone else's paper or like just seeing a mathematical result and you're like, how the fuck do you come up with that? Right.
Yeah.
And then,
exactly.
you know, your own research day to day is like, you're confused, you know, it's like incrementally, you typically, you know, you have some idea, some intuitive idea, and then you're like, there's some like core idea that is like maybe not that complicated, and then you end up formalizing it and extending it and like, you know, just modifying in certain ways, and then you end up producing a paper that then other people are like, how the fuck did you come up with that? Right. Whereas like the process is quite simple to you, right? You're like, actually the core idea is not that complicated, but then once you formalize it, it looks intimidating, and then once you formalize it, you also realize, oh, we can extend it to this, etc. Right. And so, and I always like tell people this advice when they're like getting into research, like you're going to read papers, you're going to be intimidated. You're going to think that everyone's smarter than you, but people, one, have just been doing this for a long time. And two, most ideas are like not that novel, or are like, there's a core insight and it's just been like extrapolated. And then once you add a bunch of math on top of it, it looks amazing. Right.
Yeah.
And so each one of these like little steps though, I can imagine a system being able to kind of do that. Right.
Like, you can imagine it, but you can imagine it after it's been done. Right. Like after it's been done, you can imagine training a system to follow the steps that have been laid out. But like in the process of doing it, it's very unclear what the next step is. And very often the next step emerges through this failure. Like I have an idea and I explain it to you, and then you say, well, that's not going to work, but what about this other thing? And then you tweak it a little bit. And then at the end, you get this like concatenation of steps that all have led somewhere, but you don't, when you're 10 steps before, you don't know where that 10th step's going to take you. Right.
Yeah.
And so, but then you can say, you can imagine a system doing that, but it's only after you've taken all these 10 steps and you can
imagine a system doing one step of that at a time. And that's all you need to get the 10 steps is like, if you can just do one step. Like not always, like I don't want to say like we can easily do this. I just want to say part of me is like, I don't think it's not like I'm walking down the street sometimes and then I'm like, holy shit, that was a crazy idea. Like often it's like fuzzy. I'm just like, I have conflicting ideas in my head. And then I'm like, well, like how does, you know, and then you slowly kind of realize you actually know something. And you know, it's just like, it's so slow and gradual. For me, at least. So it's like, it's rare that I'm just like struck with some amazing novel idea. And so just given that the incremental nature that I feel like true creativity, I feel like is very just like incremental, and you're kind of modifying, squishing new ideas into one another, and then taking an insight from another thing and, you know, putting that in there somehow. Just given that it feels so incremental, I don't know. I'm just like, well, maybe a system could do this. I'm not sure. Okay, to make my criticism more pointed, sometimes I feel like people that are like, computers aren't creative. Like, it's like kind of you're continually moving the goalpost. Like I kind of want to think that if 10 years ago I had been like, would a system ever do X? And then GPT-3 does X a billion times, right? And then I'm pretty sure a lot of the people 10 years ago would have said, oh, it could never do this. You could never have a system do this because it would try it,
But what matters is how it's being done. And so that's why the Turing test, I think, is an outdated way to think about this stuff, because the fact that it does X is less interesting than how it does X. And if you know how, so, and maybe in this sense, I contradict myself with what I was saying about Popper in the last episode. A system does X, and 10 years ago, you couldn't imagine it does X. But then it does X, and you say, oh, but that's not true intelligence, and you move the goalpost. I agree that's goalpost moving, but I think this is a consequence of the Turing test being a bad test, because what we need to be impressed by is not that it does X, but the means by which it does X. And if we think that if there's any reason to think that that is actually intelligent. And so we don't know how human beings do what we do. And hopefully at some point we figure out how we do what we do. And Popper would want to say if we did that, then all of a sudden it would reduce human beings to be something we wouldn't want to argue with. When I would want to say, no, we're always going to be arguing with other human beings. And once we figure out how human beings have the ability to argue, then maybe that'll give us some insight into how to train other systems to have that. But the goalpost moving thing, I think, is due to the limitation of this Turing test, because you're not asking the question of how it does it. You're just impressed that it does it.
Or not even just of the Turing test, but of just the limitation of like, it when you see it. So it is true that we would have thought systems couldn't produce certain outputs 10 years ago without creativity. But then the fact that we're goalpost moving just means that we've realized that creativity is like more mysterious than we thought, or like is which I mean, there's two ways to look at it. One is just like God of the gaps, right? Creativity is like whatever's not being done by current AI. I can totally see that criticism being leveled. And the other way to look at it is like, no, we're just, because we don't understand creativity, of course this is going to involve goalpost moving, because we're just misunderstanding creativity. So we're not sure exactly what differentiates that from just like rote pattern matching. And so the fact that machines are really good at rote pattern matching is starting to show us like how much can be accomplished by rote pattern matching. But that doesn't diminish the importance of like an actual generally intelligent system having true creativity.
Yeah, exactly. No, I totally agree. And like, I think in one of my pieces with my blog post with Mauricio, I just said, like, I'm going to use creativity. The word creativity is just a placeholder word for whatever the human brain is able to do that computers don't seem like they're able to do. So in that sense, it's a vacuous word, except that it does seem to highlight, like, I always go to Nabokov and Popper as the two most creative minds I've ever read. Like there is something there, and like you can take a painter, you can take a good director, you can take a fantastic dancer. Like there is something to be discussed with true creativity, but we just don't understand it. And so I don't want to pretend like I understand it any more than I do, which is why I tend to use it as a placeholder word for just that magical thing that the human brain can do that we don't understand. And power to Deutsch for bringing creativity into the conversation, because I think that is like one of the big things that like pattern matching is just not going to be able to do, because it's just, at the end of the day, it's very elaborate lookup tables on data sets that are bigger than our brain can possibly comprehend. That's how we're getting all these crazy results with the DALL-E and GPT-3 and all that. Like they're just fed so much data that you can do some really cool things, and that's great. But the human brain is doing something else, and that's what's so wild.
It's in a league of its own, baby.
Yeah, it's in a league of its own, baby. Exactly.
Okay, I think I'm satisfied. I mean, I just wanted to, despite me still not agreeing with the AGI folks, I just wanted, sometimes I felt like there was some nuance lacking in the conversation. So I wanted to clarify stuff in my own head, but two, try and offer somewhat of a defense. I don't know how well I succeeded in that endeavor. I'm sure they'll be annoyed by us.
Cool. Well, glad some of these unresolved ideas. Like I'm really curious to see, and this will hopefully happen in our lifetimes, like when Eliezer Yudkowsky finally admits that he was wrong. And because he's been predicting like 2030 or 2040.
Yeah, I think he has a bet that we're all going to die. No, I think it's 2025. He has a bet that there'll be no human left. I'm pretty sure.
Okay, so can we all just like hold him to, like talking about goalpost shifting, like he's going to squeeze out of that one somehow, because I think he's putting so much fear and panic into the world, where people don't have the tools to, like they don't have the time to study these systems in detail. So they, by default, rely on like authority figures. And I just think that writing piece after piece about how everyone's all going to die is just unbelievably irresponsible. So
beyond that, like I think there's the general sense that like we shouldn't be pursuing machine learning research at such a high, like there's so much money going into it. My sense is that that is a bad idea. Like funding these things is a bad idea, has like really pervaded into the general discourse.
Wasn't there like some tweet? I think you commented on a tweet about someone saying like, if I had $1 million to get people to stop working on this.
So this guy's been super outspoken about, like, he comments on all of Sam Altman's tweets, just being like, stop building AGI. Like, what the fuck are we doing? He's like, we should just pay all ML. Like, he says like stuff like AGI developers. One, I have no fucking idea what that means. I'm assuming he just means like ML researchers, right? So his idea is like, just pay them all something else to go do something, or like, but people are like, you know, this tweet was basically saying someone offered me $1 million if I can come up with like a good way to like slow down some of this ML research. And I'm just like, you don't understand, like, it's like revolutionized, like protein folding, right? Like,
it's huge,
the fact that we can fucking solve that now is so exciting biologically, and like for disease, Alzheimer's and stuff. And to like, to want to slow this down is like so bad. It's like
there's
hugely, it's gonna be some huge consequences. Like,
I'd really recommend listening to Lex Friedman's recent conversation with
Dennis
Habas, because definitely on the surface they tell people they're pursuing AGI, and you can use that as a fundraising slogan. But the kind of problems that they're interested in, the protein folding, he talked about fusion reaction, like stabilizing these very hot like reactions inside of magnetic coils, and so they're targeting all these like very immediate real world problems, and doing this under the purview of AGI research, which is fine. That's like, if that's how you're going to raise money, that's great. And so trying to stop all this because you've read some stuff from Yudkowsky is just so anti-humanist, right? Because there's going to be fantastic technology coming out of this.
And it's like the definition of the precautionary principle.
Totally.
There's possible harm, so we can't do it. Right. Just like shut it all down. And also, I don't know who he thinks is going to be working on like the robustness and safety of these systems if he shuts down all ML research. Like, there's just like the fact that they think there's a distinction there of like just a bunch of people working on AGI and then a bunch of people working on safety. Like, it's just not how it works. Right. Like, people are interested in both. Their work touches on both. Like, understanding how systems do things and making them better informs the safety research of like how to make them more predictable, more reliable. Like, to just think there's like night and day there's like this race between AGI developers and then AI safety research is like just wrong.
Totally. Well, it'll be interesting to watch and see what happens in the coming years. Cool, man. This was a fun conversation, and we'll look forward to doing it again soon, my man.